In this question, it says a frustum is a cone with the end chopped off. A bucket in the shape of a frustum as shown has diameters of 10 centimeter and 4 centimeter as its ends and a depth of 3 centimeter. Calculate the volume of the bucket. So we need to find the volume for this bucket where the diameter of the top is 10 centimeter and the diameter for the bottom will be 4 centimeter with a height of 3 centimeter. So I have extended this diagram so that it is easier for me to solve this. As it says, it's basically a cone with the end chopped off. So I have extended this diagram to form a cone. So as you can see, this is the frustum here again. If the diameter is 10, that means the radius from the center will be 5 and the height remains the same, which is 3, and the base has a diameter of 4 centimeter. That means the radius for the base will be 2 centimeter. So these are the points I have mentioned: A, B, C, D and O, and I'm calling this surface, the base of the frustum, as L and the top of the frustum as M. Now I have inverted this diagram and I have taken the cross section of it. So this O is on the top now and CD is on the bottom, where CD was on the top, and AB is over here, and this is this length. I'm calling this length as X. We need to find this X first. The reason is, as we know, the volume of a cone is 1/3 pi r square h. So h means height. Over here I'm calling the height as X. So if we don't know the height for the cone, we can't solve it. So my intention is to find the volume of the whole cone and also the volume of this cone, and if I deduct it from the whole cone, then I will get the volume for the frustum. Okay, so I will be finding the volume for this whole cone and I will deduct this volume of the cone, the small cone. So after I've inverted, this is X, this becomes 2, this remains 3, and this becomes 5. Okay, now you see that these two triangles, these OAB and OCD, are identical. The reason is this angle is common on both the triangles. This is 90 degree, this is 90 degree as well. Since this is height, that means this becomes 90 degree, and that leaves us with this angle for both the triangles. It has to be equal. If these two are equal for both the triangles, then this has to be equal as well. Okay, so that means we can use the similar triangle method to find the length of OA, which is X. So CD divided by AB is equal to CO divided by AO. Okay, so I've used those values for CD and AB, which is 5/2. CO becomes X plus 3 because this is X and this is 3, and CO has to be X plus 3 divided by AO. AO is X. So then we can find the value for X, which is 2. Now area of L. So this was area for L. I'm calling this the area of the bottom of the frustum as L. So area of L is pi r square. We know the radius for the base is 2, so it's simply 4 pi. And area of M, which is the top of the cone, sorry, top of the frustum, you can say, it is pi r square, so radius is 5, that's why it's 25 pi. Now the required area, which is the volume of the this will be volume, not area. So the required volume is 1/3 into base area into height. So 1/3 into M, which is this. into OC, which is the volume of the bigger cone. Okay, volume of the bigger cone. So 1 by 3 m into OC minus volume of the smaller cone, which is 1 by 3 into L, 1 by 3 into L into OA, because that is the height for this cone. So that gives us the value, and we found the value for m, which was 25 pi. OC is 3 plus 2, which is 5. We got the value for x over here. So OC is 2 plus 3, which is 5. And 1 by 3 into L into OA. 1 by 3 into L is this area into OA. OA was x. We got the value for x is 2. So if you deduct the volume of the smaller cone from the bigger one, then you get the volume for the frustum, which is 123 cm cube.